Hello everyone, in this video let's discuss about 2 is to 1 multiplexer. You can call this 2 is to 1 multiplexer as MUX also. So what this 2 is to 1 multiplexer denotes means, in the multiplexer we will be having two number of inputs and only one output. In all types of multiplexer, whether it may be 2 is to 1, 4 is to 1, 8 is to 1, the 1 represent the only one output. These are used for the data communication in command line. See the word common line. Common line means only one output. Whatever may be the inputs that we will be giving, but the output will be passed through the common line. That is single output. So now let's draw the block diagram. Later, using that block diagram, we will be writing truth table, characteristic equation and logic circuit diagram. This will complete the problem. Now, 2 is to 1 multiplexer block diagram means it is the just representation of what are my inputs and outputs. Only one output and two inputs are there. Let me call the output as Y, and this is 2 is to 1 mux. So let's call the inputs as I0 and I1. I0, I1 are my inputs, Y is my single output. Now let's write the truth table. But you are having two inputs from which one must be selected to get the output. So here comes the concept of selective lines. Selective lines. These selective lines will be selecting which input must be given so that to get the favorable output. Here we are having two inputs. How you can represent 2 in the power of 2? That is 2 power 1 will be equal to 2. If it was a 4 is to 1 multiplexer means I will represent for 2 power 2. Therefore, two number of selective lines will be there in 4 is to 1 multiplexer. Like that only 8 is to 1 multiplexer means 2 power 3. You can represent 8 using 2 power 3 now. So 3 number of selective lines will be there in 8 is to 1 multiplexer, like that. In this 2 is to 1 multiplexer, only one number of selective lines. Let me call it as S0. So this selective lines will play major role in selecting which input must be given. So it will be taken as the input. S0 will be taken as the input and my output is Y. Since I am having only one input, possible combinations are 0 and 1. So let us assume when S0 value will be equal to 0, I0 will be given as the input to get the output at the Y. So I0 will only go into the 2 is to 1 mux and come as the output. So I wrote I0 at the output side. And when S0 value will be equal to 1, I1 will be the output which will be coming through 2 is to 1 multiplexer as the output. Now we designed the truth table. Using this truth table, let's write the equation. So you will be writing the equation for the output. My output is Y. So if you see here, S0 is used. S0 value is 0. So you can write S0 bar. Bar represents its value is 0. S0 bar, and which input it is giving? I0. To get the I0 as the output at Y. So S0 I0 plus another possibility is when S0 value will be equal to 1. So you just write S0 and its value will be equal to I1. So S0 bar I0 plus S0 I1. Now using this equation, let's write the logic circuit diagram. If you see, I am having S0, I0, I1. This is I0, this is I1, this is S0. Now first let's design S0 bar I0. So I0 will be taken straight. S0 bar means you will be adding NOT gate in front of S0. So S0 into S0 bar into I0. So we will be adding AND gate. Next here S0 I1. So S0 I will be taking from here itself. I1 using the AND gate because in between them dot is there. Now you must add both of them. So you will be using OR gate to add both of them. Now you got the final output Y. So this is how you design the 2 is to 1 multiplexer. Hope you understood the concept of the multiplexers. If you have any doubt regarding this topic, please do comment below. I will clarify it. And the full video links of the full playlist link of the digital logic design is given in description. You can access it with the simple understanding and using simple tricks. So thank you.